Okay, we're at the last section, section 8.5, power. Um, let's share the PowerPoint, and let's say a man, he tries to get a refrigerator up a ramp uh, using a short ramp. It takes a lot of energy, a lot of power to get it up there. So next time he has to do it, he uses a longer ramp, and he notices that it's different, and it takes a lot longer time, but it is easier to do using mechanical advantage. Um, and what's the difference between the short ramp and the long ramp? Well, it's the time involved in going up the ramp. So the power is defined as the time rate of change of energy, um, the time rate of change of energy, dE dt. So that the average power is equal to the work divided by the time, delta T, work divided by the time. Um, so the instantaneous power is the limit as delta T approaches zero of work divided by delta T. And so it's the time rate of change of work. Um, so dW dt. dW is equal to F dot dr. The work is equal to F times R. So dW is equal to F dot dr. And so power is equal to dW over dt, and which is the force times dr dt equals the force times the velocity. And velocity is dr dt. So notice the work over time is joules per second, and force times velocity is kilogram meters per second squared, and meters times meters per second. So you get 1 kilogram meter squared over seconds cubed. The 1 horsepower equals 746 watts. Okay, 1 watt is equal to 1 joule per second, or 1 kilogram meter squared per second squared. 1 horsepower is equal to 746 watts. Oops, wrong way. 1 kilowatt is equal to 10 to the 1,000 watts times 3,600 seconds, which is 3.6 times 10 to the 6 joules. 0.1, an example, you have a 100-watt bulb for 1 hour. 100 watts is 0.1 kilowatts. So 0.1 kilowatts times an hour, 3,600 seconds, is equal to 0.1 kilowatt hours. So it's 3.6 times 10 to the 5th joules. And that's a wrap up of chapter 8.